For today's vocabulary notes, you will need in class 75. This is part 4 of standard 17 about angles and arcs in circles. Today's focus is on angles that have vertices outside the circle. So far we've covered angles that have a vertex at the center, angles that have a vertex on the circle itself, somewhere around the circumference. Yesterday was angles that have a vertex inside when two chords intersect. And today we're talking about angles that have a vertex outside the circle. So because of this, all of our angles to focus on today are going to be called exterior angles, and there are 3 different types of exterior angles. So if we fill in the generic definition, an exterior angle is any angle whose vertex is outside a circle and whose sides are formed by a combination of secant and tangent segments, lines, or rays. So a combination of secants and tangents. When we find the measure of an exterior angle, it's going to be similar to our vertices that are inside with those chord angles, but instead of the measure of the exterior angle being half the sum, like it was previously, it's actually going to be half the difference of the 2 arcs that are intercepted by the angle. So before we were averaging, adding 2 arcs and dividing by 2. Now we're doing a similar process, but we're going to be subtracting, that's what difference means, and dividing by 2. Now when you subtract, you have to be a little bit careful about the order. So we want to make sure that we're always taking a large arc and subtracting a smaller arc so that we don't get negative angle measures. But our formulas are going to look very similar down here to the ones for chord angles, but with a replacement of a subtraction in the middle instead of an addition. So what I like to do is to start at the angle. This is a secant angle because both of the sides of the angle intersect the circle twice, which means they're made out of secant lines in this case. When you follow out from that exterior point that acts as the vertex, we run into an intercepted arc between B and D, and then we run into a second intercepted arc between A and E. Arc AE is the larger one. The one farther away from the vertex will always be the larger. So for this one, we would take the measure of that larger arc AE, and we would subtract the measure of that smaller arc BD, and then divide by 2. Our second example still has angle C on the exterior of the circle, but this time it's made out of a secant and a tangent. So this top line is the secant, it intersects the circle twice. This bottom one is the tangent, it only intersects once. And so what happens as we travel out away from that vertex is that our first intercepted arc, the smaller one, is from B to D, and then the second intercepted arc, I'm not going to travel away from D because I don't intersect the circle again, but I need to travel up to that second intersection point on the secant. So my second intercepted arc is from A around to D. Now that might be a major arc, it's hard to tell. It doesn't have a third point in there, so we're going to name that larger arc still as a minor arc, but it might actually be a major arc where we should use 3 letters. But that larger arc, the measure of arc AD, will come first, and then we'll subtract that smaller arc between B and D. But both arcs will use point D because of that tangent line. And then last but not least, if we have a situation where it's a tangent-tangent angle, then that means that this exterior angle here is formed by tangents on both sides. So there are only 2 places where the angle intersects the circle, which means that the first intercepted arc is this small one, that's a minor arc, and the second intercepted arc is attached to those same 2 endpoints, but that's a major arc, which is why this point D is sitting over here for us to use. So if we take that larger arc, the measure of arc ADB, we're going to end up subtracting then this smaller arc closer to that exterior angle and still dividing by 2. Now there's something else to know about these problems that makes the algebra tricky sometimes. If we were to take these arcs and add them together, so the measure of arc AB added to the measure of arc ADB, what do you think we would get? Look at that picture and see if you can figure it out. The measure of arc AB added to the measure of arc ADB. If you thought 360 degrees, you were right. So it could be that only one of these arcs will be given to us, and we'll have to use 360 to help us find the other. Or if there was an expression given to us, like that this arc was equal to x, then this arc would be equal to 360 minus x. So there'll be some more creative thinking that we might need to do when we're dealing with a tangent-tangent angle. All right, that's it for the vocabulary video notes for today. If you would bring those back tomorrow, we will jump into the examples and make sure you understand how to apply the ideas.